first question is, if A is equals to 315B and A plus A inverse is equals to Ki, then K is equals to what and P is equals to what? We just simply have to find the value of K and P. The expression is given, which is A plus A inverse is equals to Ki. I is identity matrix over here. For finding the A inverse, as A is already given, we're going to find the A inverse with the help of the formula, that is adjoint of A over determinant of A. How we're going to find the adjoint of A? We're going to change the positions for A and D, and we're going to change the signs for B and C, and determinant, it is always AD minus BC. So we're just going to do the calculations, and after that we're going to get the value of P, and that value of P we're going to put in equation A as I've shown in the working. So we're going to get the value of P and K through these calculations, and our answer is going to be option B. P is equals to 2 and K is equals to 5. In the next question, a matrix is given and it's a 3 by 3 matrix. The brackets representing it shows that we have to find its determinant. And how are we going to find its determinant? By expanding. By expanding what? By expanding column 1, C1. So when you're going to expand C1 and take its determinant, you are going to get the full and final answer, option A, 25. In the next question, a matrix A is given and we have to simply find its rank or its order. First of all, it's a scalar matrix. We don't need a scalar matrix, so we're going to remove it. A is given, that is 2, 5, 3, 1, minus 1, 3, and 5, 0, 3. First of all, we're going to replace R1 by R2. Then we're going to do R2 minus R1 and R3 minus 5R1. Now, none of rows is a scalar multiple of the other, so rank, now we're going to calculate it, which is going to be 3. So option B is going to be the right answer. In the next question, a matrix is given and they're saying if this matrix is singular, then what is K going to be equal to? So what are we going to do is, when we're going to put K is equals to 0, an entire row, which is R2, will become 0. So the determinant of A is going to be 0. As given matrix is singular, so determinant of A is going to be 0. So option A is going to be the right answer. In the next question, we have to find the determinant. What are we going to do is, we are going to multiply and divide R2 by ABC, and R1 and R2 will become same after that. So we get determinant equal to 0 as both the rows are going to be same. So in this case, our determinant is going to be 0, option B. Next question is, the inverse of 5331 is equals to, we just have to find the inverse, and the formula for finding the inverse is adjoint of A over determinant of A. For adjoint of A, you are going to change the places of 5 and 1, and you're going to change the signs for 3 and 3, and then for determinant, you are going to use the formula AD minus BC. After calculations, you are going to get your full and final answer, that is minus 0.25, 0.75, 0.75, and minus 1.25, option D. Next question is, the cofactor of 3 in 1, 1 minus 2, 3 is, you're going to use the general formula of A22, that will be minus 1 power 2 plus 2. It will be 1 after the calculations done, so our answer is going to be option A. In the next question, we again have to find the determinant of the given matrix. What are we going to do is, we are going to add C1, C2, and C3, that are all the 3 columns together. Then in that case, C1 is going to be 0, and if any column is going to be 0, so the determinant is also going to be 0. So option B, 0, is going to be the right answer. Next question is, which matrix is symmetric? The answer is going to be option A, because the first column is equal to the first row, and the second column is equal to the second row, and the third column is equal to the third row. So option A is going to be the right answer. Next question is, if A is equals to this, then determinant of A is equals to what? You're just simply going to expand by C1, that is the first column, and you're going to find the determinant by AD minus BC, and then you're going to get the answer 0, that is option C. Next question is, if A is equals to this, then A is a scalar matrix, option D, as for the definition says. Next question is A is equals to this, then minor of A21 is equals to what? For finding a minor of A21, what are we going to do is, A21 is in the first column, we're going to subtract that. A21 is in the second row, we're going to subtract that. So the column and the row has been subtracted. What is left behind is A12, A13 in the first row, A32, A33 in the second row, and then we're going to apply the determinant brackets on it, so option C is going to be the right answer. Next question is, let A is equals to this, a matrix is given. The only correct statement about the matrix A is, what is the correct statement? The correct statement is option D, which says that A squared is equals to identity matrix. A is given. When you're going to take the square of it, you are going to get 0, 0, 1, 0, 1, 0, and 1, 0, 0, and it is an identity matrix of a 3 cross 3 matrix. So option D is going to be the right answer. The next question is, A is equals to 1, 1, 2, 2, 1, 1. There are 2 columns and 3 rows, and we have to find the square of it. The answer is going to be option D, not possible. And why it's not possible? Because if you have to find a square of any matrix, the number of rows and the number of columns should be equal, must be equal, okay? So because the number of rows are not equal to the number of columns, therefore it's not possible. The square of it is not possible. Therefore option D is going to be the right answer. Next question is, if A is equals to 2, 1, 5 minus 3 and B is equals to minus 2, 4, 3 minus 2, then 2A plus B transpose is equals to what? A is given. First of all, let us multiply 2 with A so that we can get 2A. It will be 4, 2, 10 minus 6. For B, they have not asked about the matrix B, they have asked about the B transpose. How we're going to find the B transpose? The number of elements in the first column are going to be the number of elements in the first row. You're going to convert them. Similarly, it will be for the second column and the second row. So our answer is going to be, when we're going to add them, it will be 2, 5, 14 and minus 8, option D. In the next question, they're simply asking about the matrix, that what is the form of this matrix. So it's an echelon form according to the definition, so option A is going to be the right answer. Next question is, let A be a 3 cross 3 matrix, means that it's having 3 rows and 3 columns. And suppose that the matrix B is obtained from A by the following row operations. R1 and R2 is interchanging, whereas R3 is converted into R3 plus 5R2. If the determinant of A is equals to 12, what is the determinant of B? It's a simple question. You don't need these expressions which are given for the interchanging and conversion. What you have to do is, they're simply telling you that the matrix B is obtained from A. So the determinant of A is 12. So as they are interchanging, so the determinant of B is going to be minus 12. When you're going to exchange or interchange two expressions, a negative sign is to be held between them. So option B, minus 12, is going to be the right answer. Next question is, if a matrix has 28 elements, what is the number of possible orders it can have? For finding the orders of 28 elements, what we're going to do is, we're simply going to find out the factors of 28. There are 1 cross 28 and 28 cross 1, 2 cross 14 and 14 cross 2, 4 cross 7 and 7 cross 4. They're total 6 in numbers, so option B, 6, is going to be the right answer. Our last question is, total number of possible matrices of order 2 cross 2 with each entry 2 or 0 is. For this, you have to remember that we have only 2 elements, 2 or 0, and we want to make matrix 2 cross 2 order. So formula that we're going to use will be 2 power 4, that is going to be 16. So option C, 16, is going to be the right answer.